We'll start. Hello everyone, this is Yogesh Kulkarni, and I'm the co-founder and COO of Altizon Systems. We primarily work in Internet of Things platform, and we have several solutions and products on the Internet of Things. This gives me immense pleasure to have this webinar and address all of you here. Thanks a lot for your time and making sure that you attend us. The topic of today's webinar is how can we leverage IoT for IT-OT convergence. I'm really not going to spend a lot of time on what is IT, what is OT, because that's something that all of us are really aware of now that IoT is becoming a very hot topic. So first of all, thank you all for attending this. There was a little disappointing day today because Indian cricket team lost to Australia in World Cup semi-final, but nevertheless you guys still managed to join, so thanks a lot for that. As we all know, the IT-OT convergence or the applications of IoT are in various verticals, be it connected health, or be it automotive or manufacturing, be it consumer electronics, be it telecom. You will find IoT solutions in almost all verticals. The topic that I have chosen today is also applicable to various verticals, but we have to focus on one vertical so that we could take some examples or discuss about some case studies. So the topic of the choice of vertical for today's topic is manufacturing, and you may be wondering why I have spelled it this way, because with all this manufacturing 4.0 or industry 4.0 buzzwords floating around, there is a lot of acceptance to IoT, especially in manufacturing domain. That is what we have been seeing with our customers as well. And in computer science, there was a famous scientist called Alan Turing, and that's when these IT systems or IoT or computer science technologies helping the manufacturing. We believe that manufacturing is now finding their internal Turing, and that's why I spelled it this way, evoking the great scientist from computer science, Alan Turing. So that being said, let's move on. Let's see where all what is really OT, and what kind of data do we get out of OT. So if you really see, OT exists everywhere. Even in our choice of vertical today, manufacturing, right? There are lots of systems that deal with actual running of the plant or the equipment itself. A lot of event-driven systems are available with a lot of embedded software. You'll see a lot of control systems with PLCs, with data acquisition systems, and so on and so forth. So if you look at a typical plant, be it a discrete manufacturing plant or be it a process industry plant, you'll find that plant has thousands of devices and sensors, with a variety of devices, with some degree of embedded intelligence, for real-time performance monitoring. The challenge when you look at this whole data, not in isolated mode, but when you look at this data has three major characteristics, which basically categorizes this kind of data as big data, is what we call it. First of all, this data is of variety of nature, because there are analog sensors, there are digital sensors, there are other control systems, there are tags. In if you purely talking in terms of OPC or control systems side of it. So the data, there is a lot of variety to it. Sometimes it is also signals directly, electrical signals from the systems. That is first. Second thing is there is a lot of volume to it, because imagine a process industry, and there are around, let's say, 10,000 tags which are being sampled every 10 milliseconds, and this is continuously running for 24/7. Or let's take another example of a CNC machine which generates around 20 parameters of data with 20 sensors, but this data is generated every second or every half a second. And then imagine 2,000 of such machines. Suddenly the volume of this data is really big. And of course, there is a velocity to this data, because this is all these industries, whether it is discrete manufacturing or process industry, right, is continuously running. And the amount of data that gets generated in real time, right, really actually gives a lot of velocity to this data. And hence, we call it big data. When we look at the nature of the data that exists as of today, this OT data is actually caught up with what we call as data island problem. A lot of data exists, we just saw that, but this data exists in an isolated manner only on either the device or that equipment. This data is not really shared across systems, and especially with IT systems, because if I have a CNC machine or for process industry, I have a furnace in chemical industry or oil and gas industry, right? All this data exists, but it is there only, and primarily used for HMI, primarily used for displaying these parameters to the operator who is actually using that equipment or using the system. But this data is not really used by any other IT systems. So and just to give you a couple of examples over here, if you look at, let's say, discrete manufacturing industry, a lot of machine data is available on the CNC machine or on the PLC control systems, but the production data, and you can obviously extract production data out of this out of this PLC's systems, but this data is never entered or is actually manually entered into the ERP systems, what we call as production booking. Or if you take in process industry example, right, a lot of operational parameters are collected through OPC servers and through connected control systems, but this data is hardly used for predictive maintenance of those systems, and to provide either proactive support or predictive predict the maintenance by using analytics on top of it. And of course, there are few systems available which could do that, but those are quite expensive and very niche to a particular segment of that industry or to a particular company. But these are the the challenges that we have. Now the question is, with IoT, if we can get this OT data and make it work with the IT systems, that will be phenomenal. So as the devices or as the equipments are getting smarter and smarter in the physical world, all the problems that we are and all the advantages that we have in IT systems can be used to basically deal with this data, or to use this data to give some business value out of it. And that's what we will look next. Now that being said, let's look at the maturity level that exists when it comes to industrial analytics, because if we cannot really analyze this data, we cannot put analytics on top of this large or big data, we cannot really derive any business value out of it. If you want to look at the industrial analytics maturity, I have taken help from Gartner image over here, where there are essentially 4 levels of the maturity curve. The first level is, of course, monitor, where you need to basically identify how you are going to converge IT and OT together, right? How this OT data can be merged, used in your IT systems, right? How does OT, basically OT looks like IT. Is it happening in your business? That's first. The second step is that you basically want to diagnose and control, because the traditional OT systems are really not aligned with IT as of today. So a consensus, that need to build, to converge, and which also means that, there is a change in how do you manage this OT data. The third level is, of course, manage, where, you want to basically manage the internal processes, people, policies, and see how, the alignment of, how you manage your OT with how you manage your IT, because in many times the IT management is a completely different ballgame as opposed to, how you manage your control systems or your OT. And of course, the fourth level is, you basically integrate these two systems and optimize. And if you look at the diagram below, it basically tells you what are the kind of IT systems that exist in enterprises and what are the kind of OT systems that exist in enterprises, and what kind of data that can really mash up and give us the context, the visualizations, the predictions, or the monitoring, and what are possibilities open up when we think about integrating OT data into our IT systems. So it could be, the state of a machine or state of a, process in the process industry. It could be smart machines or locations or condition or health of that machine, and so on and so forth. And on the IT systems, we have, ERP systems, we have our customer, relationship management systems, we have financial planning and supply chain. All this, systems exist on the IT side. With that, let's go ahead and think about, what are the possibilities if we actually, have this OT data merged or used into IT systems. And the fun here is really with Internet of Things, where these devices are becoming smarter, and people are actually having connected devices, wherein all this OT data can be pushed to a centralized platform, and then put used analytics on top of it, right? Can open up a plethora of possibilities with integrating these data points with our IT systems. So let's, in the manufacturing context itself, let's look at a couple of, the use cases or possibilities. So here I have chosen, two possibilities. One is on the shop floor, or on, and on field. So there are a few, and I'll take examples of both of these. So on the shop floor, let's say, you have connected, or you have assembly lines, or you have production lines, and you have several machines which are there, which could be anything from induction furnace to a press, press machine, to a CNC based machine, to a robotic arm, whatever, right? On the shop floor, once you connect all these devices and start getting this data out of these devices directly without any manual intervention, first and foremost thing that we could think about is that you could now do your production booking automatically, because you are listening to your machines talk, right? Because you're listening what kind of data they are sending. So this data can be used directly to be that we could inject in your, let's say, systems like SAP, and do the production booking. Second is, you could raise alarms. So for example, in an environment like a process industry or a chemical company, or oil and gas, right? If, let's say, a temperature of a particular sensor is rising beyond a particular threshold, you want to raise an alarm. And the alarm could be anything like, send an SMS, lit up a light, or send an email, or whatever. The next possibility that you could see is on the IT side, people have spent decades in defining ITSM systems, which is service management systems. And there are softwares like DMC Remedy or ServiceNow, which act like help desk tickets, wherein you could open tickets for any issues over there. Once we have all these shop floor devices connected, we could actually integrate them with these ITSM type systems and automatically open tickets. So for example, if a machine is down and down for, let's say, more than 10 minutes, right? A ticket is automatically opened and assigned to a maintenance department, so that and also alert is generated for them, so that the communication gap is automatically bridged, and there are no other extra efforts that are needed, and it also creates an audit trail and maintenance log and so on and so forth. There is also a possibility of supply chain visibility, and I'll give you an example of this with one of our customers. One of our customers is a large automotive manufacturer, and they really wanted visibility into their supply chain because most of their components are they have outsourced manufacturing of these components to their vendors now, and they primarily do the assembly job of the automotive. But now their throughput is now directly dependent on the throughput of their vendors, and to manage their supply chain and to manage their deliverables out of their plant, they need visibility in terms of how their vendors are doing. So if I have ordered 1,000 parts of a particular component to one of my vendors, right, I want to have visibility into when that vendor will be able to deliver it to me. Is it easy on time? Is it not on time? And do I need to do something else? If it's not on time, can I procure it from some other vendor? So for this visibility, they actually ask us to connect the production lines of their vendors so that they can get the supply chain visibility, for their own throughputs. So this is, some of the examples that we could talk about on the shop floor when we actually connect the devices on the shop floor and make it a smart plant. Let's take another view towards it and see what kind of advantages or benefits or systems that we could get if we have IoT enabled devices on field. So for example, let's say, and I'll take a case over here and maybe I'll quickly talk about this and take a detailed study about this. You could do predictive maintenance of your on-field devices. You could provide a proactive support. You could do the condition and health monitoring of your devices which are on field. And you could also take consumer insights. So, for example, if I'm a washing machine manufacturer and I want to, take insight into how my consumers are using my washing machines, and, from a particular geography, and, how many washing cycles do they do, when do they do, what is the consumption of water and detergent and so on and so forth. And this can reveal a lot of trend and behaviors when you have this lot of data coming in real time from the connected devices on field. So let me take an example, a specific case study for an on-field customer, which is a customer of Altizon, and we have implemented this. So now just to quickly explain you the diagram on the left. We have Daytonus, which is our flagship product, which is an IoT platform, and so this company is a leading industrial pump manufacturer, and they wanted to have all their pumps, industrial pumps, connected, and wanted to make them IoT ready. So we made them IoT ready, and then these pumps have few vital parameters, around 17 or 19 of them are really vital. Example is suction pressure, delivery pressure, bearing temperature, bearing vibration, and so on, energy consumption patterns, and so on and so forth. And all these parameters are basically collected from all these sensors. All these parameters are pushed or injected into the Daytonus platform, which is an IoT platform on cloud. And then web application or mobile applications have been built to make business sense out of this data. And the way they have used this data is really fascinating, because they actually do now predictive maintenance, because they not just sell the pumps, they actually sell the pumps with an SLA. Because if they have have around 2,000 pumps at a particular power plant, then they have SLAs for keeping those pumps running 24/7, right? And for that SLA, if a particular pump fails for any unknown reason, then they are hit with the SLA. Now with all these vital parameters continuously monitored, the chances of these guys actually understanding or predicting the maintenance of that particular pump, right, is very high, because you could now predict that a particular sensor is consistently giving value beyond a particular threshold and so on and so forth. So you could predict when the pump will be for maintenance. They also could provide proactive support and hence manage their spares inventory, because they could now, rather than providing a reactive support when the pump is down, they could now take a proactive approach and call their customers saying that this one particular pump is malfunctioning, or this sensor is not giving data, this spare needs to be replaced, so I'm sending my engineer to do that. They could also do the condition monitoring of the situations in which the pump are operating, and the operating parameters are captured, and they also can they're actually sending all this data back into their R&D, so that the design of their pump itself can take care of the monitoring feedback. And we also talked about consumer insights, where they also want to fight against false warranty claims. So these are some of the examples of how IT/OT convergence can benefit us once we have IoT enabled equipments either on field or on shop floor. That being said, it's also not very easy. There are lots of challenges when you really want to do IT/OT integration. First and foremost challenge is, as we discussed, it's big data. So there is a lot of volume, there is a lot of variety of the data, there is no structure to the data that we will get, and hence we need a IoT platform, a very, very ruggedized IoT platform like the ones that we have, which can basically deal with let's say a billion events from a million devices in an hour or in a day, right? So, and it could also do real-time processing. It has a big data stack around it, can do a lot of map-reduce algorithms or aggregations in the back end, so that the analysis of that data is also very useful. Of course, there are evolved IT infrastructure that is needed, because since it is big data, a lot of traffic, a lot of compute elements are needed, and hence there will be a IT infrastructure need which we need to adhere. Fortunately, we do not actually put a lot of burden of IT infrastructure on our customers. We have platform as a service. We have hosted the IoT platform, and hence the IT infrastructure overhead is really not on our customers, who actually go for SaaS model or platform as a service model. But if they really wish to deploy it in their own data centers or on premise, right, that deployment is also possible. But in that case, the IT infrastructure challenge will come in. There is of course a security and risk management challenge over there, because you really need to know who can access this data, and what that person can do with that data, or what that user can do with that data, because you cannot really have this all data open out to anyone who can poke his nose in this, right? And that's why we have a complete role-based access control model in place, so only authorized people can see only authorized data. There is legal and privacy framework that is that needs to be addressed. For example, the case that I talked about, the manufacturer wanting to see the production data of its vendor, right? And how do you then legally protect your own interest, and is it legally allowed, or how do you take care of the privacy measures, and so on and so forth. And of course, when it comes to on-field, if you have a power plant and I'm going to deploy all these connected devices over there, how do we take care of actually sending all this data to be consolidated on a central location? So network technology is also something that is really needed over here. It's either and do you want a one-directional communication, bi-directional communication, and so on and so forth. So whether you want to ride on to the corporate network, or whether you want to ride on to the 3G or 4G mobile networks, or whether you want to, what kind of protocols that you want to use, whether you want to stick to HTTP or use a very specialized protocol like MQTT, and so on and so forth. So all these challenges, exist there. But fortunately, there are companies and platforms available who have already addressed such challenges, and nonetheless they still exist, and but they are addressable. Definitely, they are addressable. And so we talked about manufacturing right now, but all these challenges, all these applications also exist in other verticals also. And quickly let me take one example of smart grid or smart cities. if we have energy meters connected, water meters connected, gas meters connected, right? The utility billing and the management of these meters and so on and so forth, right, is also possible when it comes to smart cities. So you think about it, and if you could start thinking about this, right, we could perhaps talk for the whole day over here in all the possibilities about that we could achieve with IoT integration once we have lots of connected devices. So that being said, I'll leave you with this note, and thank you very much for listening to me.